everyone, we're going to find the intervals on which f is increasing or decreasing. Thus find the local maximum and minimum values of f and find the intervals of concavity and the inflection points. And this is our function where the interval is closed from 0 to 2 pi. So the first thing we're going to do to test the if f is increasing or decreasing is to take the first derivative of f of x. So that's just going to be f prime of x equals a derivative of sine is cosine, and the derivative of cosine is negative sine. And then you set this to 0 to find the gradient. So we're going to get, if you add cosine to both sides, sine to both sides, you get cosine of x equals sine of x. If you divide both sides by cosine, you get 1 equals tan of x. Therefore, our angles where tan of x equals 1 is x equals pi divided by 4 and let's just put 5 pi divided by 4. All right, now we're going to test for increasing and decreasing from 0 to 2 pi. So I'm going to do a sine diagram. And we're going to do 0 to 2 pi and put in our critical values. Pi divided by 4 and 5 pi divided by 4. Now, we want to know where, and I'll just erase this, where this is positive, that means it's increasing, this is what this says, and where it's negative. So I can say where cosine of x, if I add sine to both sides, is greater than sine of x, and then if I make it negative, then that would be cosine of x is less than sine divided by x. And these are the intervals we're looking at. So if we just look at 0, you can plug in 0 to pi divided by 4. If you plug in 0, we're going to get 1 is greater than 0. So since that's greater than, that means this is positive. If I plug in, let's see, pi over 2, if I plug in pi over 2 into this, I'm going to get cosine of pi over 2 is 0, and sine of pi over 2 is 1. So that means cosine is less than sine. So this is negative. And then I can plug in 3 pi divided by 2 for this interval here. And I'm going to get cosine of pi over 2 is negative 1. And that's going to be, let's see, pi over 4. We'll get let's just plug in 2 pi, and then we'll still get 1 is greater than 0. So this is positive. So what this means is it's increasing on the interval 0 to pi divided by 4, decreasing on the interval pi divided by 4, 5 pi divided by 4, and increasing on 5 pi divided by 4, 2 pi. All right. So now those are the intervals where it's increasing and decreasing. Basically what this means is you're increasing from 0 to pi divided by 4, decreasing here from pi divided by 4 to 5 pi divided by 4, and then back to increasing. So this is increasing gradient, decreasing, increasing. This means this is a local maximum at pi divided by 4, and local minimum at 5 pi divided by 4. So now we have to find the exact values for part B. So all we're going to do is evaluate those. So we're going to evaluate f of pi divided by 4, and just plug that in. So that's going to be sine of pi divided by 4 plus cosine of pi divided by 4, and that's going to give you square root of 2 divided by square root of 2 plus square root of 2 divided by square root of 2, and that's just going to equal square root of 2. So we have at pi divided by 4, comma, square root of 2, that's going to be a local maximum. And then let's evaluate f of 5 pi divided by 4. So it's going to be sine of 5 pi divided by 4 plus cosine of 5 pi divided by 4. They're both negative in quadrant 3, so there's negative square root of 2 minus square root of 2 divided by 2, which equals negative square root of 2. So at 5 pi divided by 4, we get negative square root of 2. That's going to be your local minimum. All right. Now the next thing we have to do is find the intervals of concavity. And that's going to be your second derivative test. So our first derivative was prime of x was cosine of x minus sine of x. So when you take the second derivative, you're going to get derivative cosine of x is negative sine of x, and then derivative of negative sine of x is negative cosine of x, and set that to 0. So what we get is add cosine to both sides and divide both sides by cosine. So you divide both sides by cosine, you get negative tan of x equals 1, or tan of x equals negative 1. So basically, tan of x is negative 1. At our critical values, x equals 3 pi divided by 4, or 7 pi divided by 4. Now let's do a sign diagram again and test for concavity. So we have 0 to 2 pi, and we're going to put 3 pi divided by 4 and 7 pi divided by 4. So basically, if you plug in, let's see, we can plug in pi over 2, and we're going to get negative sine of pi over 2, that's just 0, minus, well, that's going to be 1, so it's negative 1, minus cosine of pi divided by 2 is 0. So this is just going to be negative. And then here we can plug in pi, and that's going to give us a positive. And here we can plug in, let's say, 11 pi over 6, and that's going to be negative. And all that tells us is this is concave down, concave up, concave down. So that means we do have inflection points at 3 pi over 4 and 7 pi over 4 because it's switching from negative to positive and then positive to negative. So we have to find the inflection points. So we're going to do f prime of 3 pi over 4, and that's going to give you 0, and we do f double prime of 7 pi over 4, and that also gives us 0. So our inflection points are at 3 pi divided by 4, comma 0, and 7 pi divided by 4, comma 0. And I just wanted to say real quick the points I plugged in to do the derivative test. So for this one, I plugged in f double prime of pi divided by 2, and I got that -1 was less than 0. For this piece, I plugged in f double prime of pi, and here I got 1 is greater than 0. And for this piece, I plugged in f double prime of 11 pi over 6, and when I plugged that in, I got this is 1 minus 1/2 square root of 3, which is obviously negative because this number is bigger than this one. So that's the numbers I plugged in, and you can plug in any numbers you want and get your positive and negatives. And that's it. Thank you. Have a nice day. Bye-bye.